Hi, my name's Callum. Let's go build rockets. Okay guys, first things first, we are still building rocket engines. I promise you we're still building rocket engines. I know it's been a long time since the last video and I'm sorry for that. But as you'll see, I've been working hard and we'll still go here. We've got some pretty big changes. We've got a new shed that is full of new toys. We're working on some new ideas for rocket engines and we've also got a new sponsor. So, you don't come here to watch me ramble on, you come here to watch us build rocket engines. So let's get going.
If you're new here, here's a little recap of where we are. About a year ago, I decided I want to build a liquid rocket engine. I'm currently doing a degree in aerospace engineering, so I thought, how hard can it be? I started off building a combustion chamber and injector and went on to design my own feed system with custom designed valves, a test stand. It all culminated in a successful ignition of failures in the feed system. So this time I'm upgrading everything as much as I possibly can to see if we can get this engine to sustain a hot fire. And I make no promises, but as SpaceX say, excitement is guaranteed. Okay, let's do it. I think we can all agree the previous test stand was not my best moment. This is going in the bin. We're going to build a brand new blast resistant test stand. Okay, let's go.
This test stand is an investment. We're building it to hold both this engine and future engines. It's going to be a concrete block bunker with a steel skin to protect us from the excitement that can occur with a rocket launch. Big thanks to Tom, who helped me build the walls. He's been invaluable to this project and you'll see him again later.
Come check it out. It's a wall. 2 walls.
The steel skin blast shields will stop any shrapnel being produced by the concrete walls. They're attached to a frame of large steel box section that provides both the strength to the bunker and gives us places to attach the rocket engines to.
I'm pretty happy with that. Only got one more to go. Let's get cracking. Got a rocket to fire.
Oh, and we put a roof on it. Big thanks to my uncle for that one.
Okay, this is our new test stand. It has the thrust test stand at the front, linear rails. We've got bars behind to place the fuel tank and the valves on. 1.5mm thick steel to protect us if anything happens. 4-inch grease blocks. I feel a lot safer. Right, I've got to get a rocket on it. How hard can that be? Before we find out, I need to give a moment to our new sponsor. Onshape have been so generous and offered to support both this channel and this project. Onshape is a cloud-based professional CAD software started by the former SolidWorks founder and includes all the features you have come to expect with your favorite CAD software. Being cloud-based means Onshape will run on any computer through a browser without needing to download large applications or store large part files on your computer. It also automatically saves all your progress, so you'll never again lose hours of work because you forgot to save something. Also, as it's cloud-based, you can use your phone and tablet as complete CAD tools, being able to design on the move without having to get out your laptop. Onshape is basically the Google Docs of the CAD world and allows you to share your files and collaborate with other people so much more easily. You can even both be working on the same part file at the same time. As it's cloud-based, I can also share all my CAD files with you guys, and the best thing is it's free to sign up. So go look in the description to find links to sign up for a free account and CAD files of everything you've seen in this video. By supporting these guys, you're supporting me and the channel, so please go check it out. Okay, let's finish off this rocket. The rocket needs to be cooled, otherwise it's going to melt and we're going to end up with a splodge of steel on the floor. So we need to build a cooling system. It's going to be mainly just a lot of water going through against the chamber walls, but hopefully that'll keep it cool. The second skin's going to be made out of a stainless steel tube that we can then put the rocket engine inside. Hopefully, if I can do video editing, here you'll see CAD sign on Onshape of what the rocket should be. And we need to design the caps for both ends of the cooling system and to make sure that we can slip on and off the cooling system tube. We have to have the inlets and the outlets, and we also need fire water pump. And we've got to plumb it all together. And hopefully, the cooling system will work. That's the plan. Let's go.
And here it is, the final cooling system. One of the prettiest things I've ever welded and one of the most time consuming. The faceplate bolts onto the exit of the nozzle to create a seal around the nozzle. At the back we can clamp the injector straight into the cooling system, which just reduces parts and the complexities. And yeah, all this stainless steel pipe I think is just absolutely gorgeous. I'm really, really proud of this actually. Do a test of this system to see how it works, and then we get on with everything else.
There's a huge amount to do to get the rocket plumbed and attached to the test stand. All the plumbing has to be cut, reamed and threaded. It's got to be modelled on CAD and bent to shape, PTFE taped and then put together. The thrust test stand has to be built and put onto the linear rails, a new ignition system has to be made and the brackets for all the valves and the fuel tanks completed. Time to get my head down. With everything made, it all has to be assembled into the test stand. All the valves then have to be integrated with the electronics. We're running motors and sensors at 3 different voltages, so this is a big job. I decided to bring in an expert, and guess who it is? It's Tom. Tom connected up all the valves, wrote the code and produced the base station electronics with an emergency shutoff. He wired it all together and tested it to absolute perfection. So our final step is plumbing in the cooling system and putting together the combustion chamber, and we're ready to go.
It's hot fire test time, and we have spent hours and hours and hours on this thing, and it has kicked our ass, blood, sweat and tears, but it looks so awesome. It looks so awesome, and I'm so happy. And it's hot fire time, we're filled up with petrol, we've got pressure in the tanks, we've got loads of valves behind us, we've got the thrust sensor in there. We might get lucky, but there's absolutely no way that we can have done this without our sponsor. So big thank you to Onshape, and thank you to everyone else who's helped. And let's do it. Let's hot fire. Boom. This is the second, possibly last test for the
liquid rocket engine.
Yes, but we're not going to ignite it until you're back.
No, I hope not. Okay. Right, I'm off. See. Should we do that now? Good boy. In. Ooh. That is that. That was the hot fire test, and unfortunately, I guess it was a failure. We didn't get the full duration burn that we wanted. In fact, we got the exact same failure mode we got last time. Even with check valves, even with stainless steel plumbing, we still get backflow. In fact, you can see in the video, you can see immediately at the point of ignition, a failure in the ignition system. You can see the entire rocket body move, and it moves forwards, which suggests to me that we're getting a detonation, and that's not what we want. That is probably the end of the BEL rocket engine. It was almost heartbreaking, that failure. But on the bright side, we are exactly where we would have been if it had worked perfectly. We're going to go on, we're going to take the information that we've got from testing this experimental rocket engine, and we're going to build a new rocket engine, and we're going to build it better. And this time it's going to work, because we're going to work harder. You build, you experiment, and you learn. So, once again, thanks for watching, thanks for being patient with me. This is not over. This is not over. And I hope to see you soon. Thank you. Let's try that again.
This is so cool.
Don't like me. Let's do it. Lots of things have happened. I've just said that like 3 times in 3 different ways. That was fucking terrible, wasn't it?